Good evening, ladies and gents. We have this as a voluntary association that talks to and caters to the electrical engineering practitioners. Whether you're an engineer, engineering technologist, technician, or an artisan electrician, as long as you practice electrical engineering, you are more than welcome. We even welcome those that might not necessarily be practicing it, but they are within that area. So we have these talks in conjunction with two, if one can call that, distinct higher education institutions within the Gauteng area. So with the University of Johannesburg, we have the President's Invitation Lecture, where we invite annually a distinguished local subject matter expert to talk to us, provide us with information, and this is one of them. So more importantly, I would like to also thank the Dean here for giving us the opportunity to use his posh abode here. We try most of our events, physical ones, we hold them at our offices or at our area SAIEE house in Observatory. But we also need to get closer to our allies, and our allies are also higher education institutions, University of Johannesburg for starters. So thank you for that, Prof. Much appreciated. Thank you for heeding our call. Without further ado, let me also ask that you come and welcome the visitors, Prof. Thank you very much.
No, thank you very much. My name is Daniel Mashao, and just a little bit of introduction about myself. I am the Executive Dean of the Faculty of Engineering and the Built Environment at UJ. I did electrical engineering at the University of Cape Town, and I also used to teach there until 2006. And when I used to teach at UCT, I stopped telling students what year I completed my degree, because when I told them what year I completed my degree, I realized that most of them were not born when I completed my degree, so I stopped talking about that. But I completed my degree in 1986, BSc Electrical Engineering, and I got it cum laude. So I was a very, very good student. I am now the Executive Dean of the Faculty of Engineering and the Built Environment at UJ. Just a little bit about ourselves. We are the largest built environment, engineering and built environment faculty. We have over 10,000 students. And in terms of electrical engineering, we have electrical engineering science and electrical engineering technology. So we're a comprehensive university. We used to have diplomas, but now we have changed. We only have BEng and BTech, BEng Tech. The University of Johannesburg is really very proud that you have decided to hold this meeting here. I was thinking about a saying. My Vice Chancellor wrote a book on sayings of our people, leadership from the sayings of our people. So because of that, he got us used to remembering the sayings. And it's one saying that I remember now that says, if the mountain won't come to Muhammad, Muhammad must go to the mountain. So I think it's the opposite. You have come here, and we really feel honored as a University of Johannesburg. We are, one of the youngest universities. We are doing our best. We have a vision of being the best international university of choice, anchored in Africa and the global south, and dynamically shaping a sustainable future. As a university, we really live to that vision. We really live to that vision. We try to do our best to make sure we meet the vision of being an international university of choice. So when you see us being ranked very high, when you see all these good things about UJ, they are not there by chance. There's a big design behind that of really working on that. We firmly believe that access and excellence do not have to be exclusionary. You don't have to be accessible doesn't mean you have to stop being excellent. So we really believe in that we will be excellent and will also be accessible. About 70% of our students are NSFAS funded. So that tells you a little bit about where we come from, that most of our students are first generation in their families to be able to do a degree. While talking about that, I can talk about myself, that when I did my degree at UCT, it was during those times when you had to apply to the Minister of Education to be able to go to UCT. But I did have a privilege of going to study in the US at Brown University and doing my PhD on AI. We didn't call it AI then. We call it neural networks. Then when I did my PhD in 1995, and I obtained my PhD there. And as far as I know, I was the first Black South African to get a PhD in engineering at that time. Yeah, thank you very much. Yeah, so it was an honor to really do that. I'm now looking at our university where we do have many challenges. We have many challenges. We have the triple challenge of the country, but we also have many challenges, and some of them are very sad. I mean, one of the saddest things that we are having now is that as a university, we can only accept 2,000, as a faculty of engineering, we can only accept 2,500 students every year. And when I joined UJ, it was a very, very hard target to meet. But from last year, it's really, really very easy. So there are many students who finished their high school with university entrance, but that we cannot take. So it's really beginning to be one of those big challenges that we are not able to accommodate all the students. We have to tell many students that at UJ, we can only take 2,500 students. We can't take any more. And the students are passing very well. They're doing very well. They are realizing the value of education, but we are not able to cater for them. Part of, as I said, the vision of UJ is to be an international university of choice anchored in Africa, and I want to talk a little bit about that. When we talk about being anchored in Africa, we are talking about being relevant. There are many projects that are done in this faculty that are looking at being relevant to South Africa, because South Africa has challenges that we need to solve. We don't see ourselves as a university that is not dealing with our situation. For example, you might know about the 40-40-40 problem that we have in this country, that many of our people live in 40 square meter houses. They live 40 kilometers away from work, and they spend 40% of the meager money that they get on transportation. So as a university, we really are looking at ways of being a solution. 2 years ago, we launched the 3D printing of RDP houses. It's a project that is still ongoing in the faculty, but we are doing other things. We have a smart village in Gwakwane where we are trying to bring in technology. And the topic that we are dealing with today, it's very relevant to us because it's a topic about energy, about what do you do where we are right now, where the continent is right now, the continent that has challenges which we must see in a positive light. We must try to make the best out of it. We must try to use our youth dividend, to good effect, because we have it. We have a lot of young people, and we need to find ways of ensuring that we can empower them to do well. UJ has UJ Digital, which is a part of our university that we are trying to bring online to be able to assist. And as you know, the last part of our vision says dynamically shaping a sustainable future. We're looking at AI and artificial intelligence. We're looking at what it's going to do. And I can tell you that I did my PhD on AI, but even me, I'm really just amazed by the improvements that we have in AI. I'm just really, really impressed. I can see how it's going to change education of the future. You know, just briefly, most of our education includes two components. One component is memorization, the other component is understanding. And most of, maybe let me not talk about engineering, let me talk about medicine. If you look at medicine, the students might be spending 6 years there. But you know, part of that 3 years they're spending there is to memorize things, to know names of parts. And AI is coming to us and is saying to us, maybe you don't need to do that anymore. You know, maybe you don't need to do that. Maybe you can reduce the size of the degree. You know, and I think even for engineers, we need to ask ourselves, what does AI mean for us? But I can talk forever. As you can see, that's the reason I'm the dean of this big university, but I'm here just to really invite you, to welcome you, and also to challenge you to participate in this kind of discussions. Because together we can do more, together we can understand more, together we can bring solutions. And lastly, some of you might know Phumlani Moholi. Phumlani Moholi, when I was at UCT, because the black students were so few, you knew everybody. So I know that 2 years ahead of me was Pinky Moholi, who at one point was the CEO of Telkom. But Phumlani Moholi was just 1 year ahead of us, and we were very few students. I think when I was there, we were about 6 students at UCT, black students at UCT. So just the sad news that Phumlani has passed on this week, and I think he'll be buried probably on Saturday. So it's a sad news, but those were our heroes, because when I went to UCT, because of our few numbers of electrical engineers, that you already knew everybody who was in second year, who was in third year, and so on and so forth. So colleagues, without much further ado, I just want to say you are welcome at this great University of Johannesburg, and hopefully we'll have many more meetings to be able to discuss these things and bring solutions to our country. Thank you very much. Welcome.
Good afternoon, everyone. Glad to see a good attendance. Firstly, let me thank Dean Mashao for allowing us the opportunity to be at his university for this presidential invitation lecture. It is a tradition of SAIEE that we have 2 really big events in the year. One is the presidential invitation lecture, where we tend to invite people that are renowned in the industry to come and impart some knowledge to us on current affairs. And then the second is the Bernard Price Memorial Lecture that takes place in a few months' time. For both these events, as a president, I've taken the opportunity to look at people that I studied with at university and approach them to come on board and to deliver these lectures. And I'm glad to say that Dr. Nad Moodley is one of them that was at university with me and willingly accepted the invitation to come and present to you today. So I'm quite honored that he is here. As an institute, my message for this year is really on the value that we as an institute add to our members. And I've been saying this during the course of my inauguration address and also during the course of this year that I am the president, is that the value of an institute will only be appreciated if our members see themselves as growing and contributing to the development of the country. And this is one of such events where we create opportunities for our members to network, for members to get new knowledge, and then to grow in their respective careers as well. So I see a lot of young individuals here, and probably a lot of student members that are with us, which is really, really great and encouraging. And I really hope that you remain as members of the Institute once you become professionals and once you have completed your degree. But enough said in terms of introduction. I think the CEO had covered a lot of that. Let me then do the most important task today, which is to give you a bio of Dr. Nad Moodley. Dr. Moodley is an engineering and asset management leader that has got more than 30 years of experience in the industry. He has worked in the power utility sector. He's got a string of qualifications, and I think it's quite impressive. And I will not be doing justice if I just skim through it. I think I really need to emphasize the qualifications that he holds. He holds a PhD in engineering from the University of Cape Town. So, Dean, just as yourself, a graduate from the University of Cape Town. He's got a master's in business leadership. He's got a Bachelor of Commerce degree, and he holds a BSc in electrical engineering degree from the University of Natal, now called University of KwaZulu-Natal. He's registered as a professional engineer with the Engineering Council of South Africa. He has his government certificate of competency, which helps in terms of the Occupational Health and Safety Act. Dr. Moodley's career began as a systems engineer at Creole Power Station, where he developed long-term transformer replacement strategies and introduced innovative condition monitoring practices. Thereafter, he joined Peaking Generation in 1997, and he has worked across hydro, pump storage, gas, wind, solar, and open cycle gas turbine technologies. Today, as an asset life cycle manager for Eskom Peaking Generation, he orchestrates the entire asset life cycle. He also chairs the technical design committee and serves as the engineering change authority for 14 power stations. In these, he makes critical decisions in ensuring the plant's operational availability and addressing emergencies. His leadership has shaped major capital projects, driving resilience programs, and extending asset life. He's also introduced advanced condition monitoring dashboards to support executive management decisions. He is also the proud recipient of multiple Eskom Excellence and Chairman's Awards, and he's presented papers internationally and has contributed to SAIEE as well. Let me stop at this point and really hand over to Dr. Nad Moodley, who will speak to us on a very interesting topic that's absolutely topical right now. We do know that Eskom's energy availability factor is at the all-time high in recent years, and Deputy President Prudence Madiba will correct me if I'm wrong, but I think it's around about 64.7% or in the mid 60%, which is phenomenal from where they've been. And I think a talk like today's will really keep us interested in terms of what is Eskom doing to keep us at that level or to take it even higher to where it has been historically. So with that said, Dr. Nad Moodley, let me hand over to you. Thank you.
Good evening, Mr. President and distinguished members of the SAIEE, Professor Daniel Mashau, the faculty and students of University of Johannesburg, respected colleagues and fellow professionals in the engineering fraternity. It is a true privilege to address you this evening on a topic that cuts across all disciplines and sectors in our field: the effective management of assets to ensure consistent delivery of reliable services, even in the face of mounting constraints and rapidly changing environment. When I was invited to deliver the President's invitational lecture, I took a moment to reflect. There is no shortage of issues we could discuss, especially in the current climate. Over the past decade, Eskom and its engineers have found themselves under intense scrutiny, often overshadowed by negative press. But I firmly believe that some of the finest engineering minds reside within Eskom. That is why tonight I choose to focus on the positive. Drawing on over 30 years of experience within Eskom and the Peaking Generation environment, I hope to offer some insight and context to show that despite the challenges, performance excellence is possible when we return to and reinforce the fundamentals. In my lecture today, I will go through an introduction of the peaking operating business. We'll look at the critical functions that the peaking power stations play in supporting the grid. We'll look at the peaking performance. Then we'll look at some of the current operational challenges that we face. And then I would like to discuss a concept called resilience engineering. And then we'll go into the conclusion. Right, so Eskom peaking power stations. Peaking generation currently consists of 14 power stations covering the hydro, pump storage, gas, and wind technologies. It is the largest operating unit in generation, with an installed capacity of 5,865 megawatts. The power stations are distributed throughout South Africa, with our central office in Cape Town, where we provide all the supporting services like engineering and finance and procurement. So I will go through each of the technologies and the different power stations just as an introduction so that everyone is aware of the peaking generation operating unit. So I'll start with the pump storage. We have 3 pump storage stations in the fleet. And as many would know, a pump storage plant is a type of hydro facility that acts as a large-scale energy storage system. It uses 2 reservoirs, a top dam and lower dam, and during low demand, we pump the water up, and when it's required during high demand, we release the water and produce electricity. Drakensberg pump storage scheme is the oldest of our pump storage units. It was commissioned in 1981-82 and is located in KwaZulu-Natal on the Van Riemen's Pass. Drakensberg consists of 4 units of 250 megawatts each, with a total capacity of 1,000 megawatts. The next pump storage station that was commissioned in 1988 is Palmit. And Palmit is located on the Overberg in the Western Cape. It has 2 units with a total capacity of 400 megawatts. And it plays a major role in supporting the Western Cape. But I'll go through more details of that in terms of the functions. Then we have Ingula Pump Storage Scheme, which is our flagship. It's our newest edition. It was commissioned in 2015-2016 and consists of 4 units of 331 megawatts each, with a total capacity of 1,324 megawatts. I must say, all 3 pump storage schemes have been playing an invaluable role in supporting the grid. The next technology that we have is the hydro station, which is a run of the river, which means that when we produce the electricity, the water is lost, it's gone, right? So we have 2 major power stations on the Orange River. The first is Kharip Power Station, which was commissioned from 1970 to 1976. So it's very old. It is located in the Eastern Cape, consists of 4 units, 90 megawatts each, total capacity of 360 megawatts. Downstream, located in the Northern Cape, is Van der Kloof Power Station, which is on Van der Kloof Dam. Was commissioned in 1976, and it consists of 2 units, 120 megawatts each, and a total capacity of 240 megawatts. The next group of hydro stations, as you can see at the bottom in the Eastern Cape, is, as we call, small hydros. So those are little hydros. They were part of the distribution, but over the last 3 years, it's been handed over to peaking. Unfortunately, they are not in an operable state, but except for 2 units at Nocha. However, we are trying to find a way of rehabilitating these power stations. The next technology is the gas stations, right? And we either have OCGT or aeroderivatives. Ankele Power Station is the biggest of the OCGTs. It is located in Atlantis, in Cape Town, up the west coast, and consists of 9 units with a total capacity of 1,327 megawatts. Then we have the sister station, Khorikwa, which is located in Mossel Bay. And Khorikwa has 5 units, total capacity 740 megawatts. Our old stations, Acacia and Port Rex, they are aeroderivatives, which means they're actually Boeing 707 jet engines, and they can run on kerosene or diesel. Acacia is located in Cape Town and supports Coburg, and Port Rex is located in East London, where it supports the grid in terms of voltage stabilization. Right, we get to our last technology that we have at the moment is wind. SAIEE Wind Farm is currently the only Eskom wind farm located in Vredendal in the Northern Cape. It consists of 46 Siemens wind turbines with an individual capacity of 2.3 megawatts and a total capacity for the farm of 100 megawatts. Right, so now that we've got a good idea of what peaking generation is and the technologies, I would like to go through some of the key functions that they play, important functions. And we know peaking, right? The fundamental purpose of the peaking units is to supply peak power during the mornings and the evenings. And these are periods where people, they start their day in the mornings and they shut down in the evenings, and it's usually an energy-intensive process. Due to the nature of the peaking plant, we're able to come in very quickly, fill that gap, and leave without anybody noticing, right? But in recent years, peaking has also been contributing to the base load to support the coal stations. And we can see in the yellow part of the curve, which puts pressure on available capacity during peak periods. This then resulted in what we know as load shedding. And I must say, without peaking, the impact of load shedding would have been much more severe. The next critical function that we play is to regulate the VARs on the system so that we can control the network voltage. Our units are unique because if you look at the capability diagram that's being presented, on the vertical axis is real power, on the horizontal axis is your reactive power. And some of our pump storage and gas units can operate purely on the reactive leg. If you look at the pump storage, for example, in this picture is a cross-section of the turbine, draft tubes, spiral casing, right? But the important part here is the white region. Now, when we run in SCO mode, synchronous condenser operation, our turbines are disengaged, but our generators is synchronized onto the grid. Now, to do that in the pump storage, we have a blow-down system which blows high-pressure air into the turbine region, creates an air bubble that allows the turbine to spin in air while the generator on the shaft is synchronized onto the grid. Thereby, we control our excitation system, and we can either supply VARs or absorb VARs from the grid. And that has been playing a major role in supporting the voltage in the network. The next function that we play, and we may think that we use up all the energy, but when there's low demand, we replenish the pump storage. And in doing so, we use some of that excess energy, preventing the coal stations from decreasing drastically in their load. So we allow them to have a very stable energy production over the day. So that's another critical function. Another absolute critical function in terms of supporting the system operator is that we can do emergency power generation, and sometimes in the grid, we are operating at a maximum continuous rating, and there might be an incident, or there might be an increase in demand, and the system operator needs extra energy, and our units are able to, for a limited period of time, between 30 and 60 minutes, we can actually ramp up to unity power factor and go to maximum, absolute maximum, beyond the maximum continuous rating. And for example, you look at Drakensberg pump storage scheme, each unit maximum continuous rating of 250 megawatts, but we can go 30 megawatts more instantly. If you look at the total of 4 units, we can provide 120 megawatts. If you look at all the hydro and the pump storage put together, the system operator has a potential of 318 megawatts to play with when they need it. And it's been used very often. Right, so the next function, and that's the nature of our plants, we are very quick. Right? If you look at the blue bar graphs of all the hydro and the pump storages, we're able to go from standstill to full load in 3 minutes. So in 3 minutes, we are full load on the grid. Acacia and Portrex, 10 minutes. Ankalak and Kurikwa, 21 minutes. Now this is in vast contrast with the cold stations, where from cold state to full load, it can take between 8 hours and 12 hours to actually get up to full. And if you look at the nuclear stations, it can take a few days. So by us being really quick, we assist the network in terms of automatic grid control, where the system operator can control our units directly when they need to. Under frequency load shedding, when we're running in pump and there's an incident on the network and it's under strain, our pump units can immediately disconnect. Right? We do instantaneous reserve, regulating reserve, where we can regulate the frequency as required. Right, so another critical function is the re-energizing of the network, black start. Drakensberg pump storage scheme is our black start station. And it's able to run up either Majuba or Tutuka power station. And once they get going, they can get the rest of the stations going, right? Ingula pump storage scheme is also able to be a black start station, and these stations are tested once a year. Right. The next function, and I'm not sure if many people know this, but Drakensberg pump storage scheme can do water transfer. Water can be taken from the Tugela River and pumped through a series of dams and tunnels where it gets to our bottom dam. And from our bottom dam, we can pump that water to our top dam, which links to the Sterkfontein Dam. The Sterkfontein Dam is one of the biggest dams in our country. And from the Sterkfontein Dam, we can release the water, or the Department of Water Affairs release the water into the Wilger River, which leads into the Vaal River and the Vaal Dam. And from what I could see, last it was done in November 2016. Right. Finally, I would like to, Acacia Power Station. Acacia, as I mentioned, is a small power station, gas station, 3 units, 57 megawatts. But Acacia plays a role as the external off-site supply for Koeberg Nuclear Power Station, which is part of the nuclear regulations to allow Koeberg to run. And without it, Koeberg will have to reevaluate, and we'll probably have to shut it down if Acacia is not available. So we play another major role where Koeberg can actually auto-start us whenever they need, right? So that's another critical function. So as you can see, peaking units have been really supporting the grid in the background. Not many people know about it, but the impact has been there. Right, so we got a good indication of who peaking is, the different power stations, we know the functions. Let's see how peaking has been performing, right? I know the EAF, right? Generation EAF is been all over the media, everybody knows it, but let's go through it, right? Now, One of the measures is EAF in terms of how well a power utility is doing and how well its units are doing. So it's a measure of the percentage of time a power plant is available to produce electricity, excluding the times when the plant is down either for maintenance or we have a breakdown or any other outages that happen. Right? So a high EAF means we're operating very efficiently. So I'm going to show you this over the last 10 years. I went through 10 years, and we can go beyond, but I'll take 10 years till 2014. The pink bar graph is the average of generation over this period, right? And we can see from 2014 to 2019, Eskom generation has been in the 70s, right? And there's been a slight decline in 2019 to 70, and then from 2020 to 2024, there's been a drastic decline, leveling out at around 55%. In 2025, our last financial year, we can see there's improvement on the generation side, and this year we are definitely pushing to improve on that. But the important thing I want to show you is look at peaking generations, and that is the average of 36 units. They have been above the 90%, except for 2 years, 23 and 24. But that's because we've had major PCLF, which is planned maintenance. We did half-station upgrades and major maintenance work. And we've also had one significant breakdown at Unkeluk GT12, where our generator failed. And there was a big impact to us. But I'll go through that, right? But you look at 2025, we've bounced back again, 97% EAF. And I just want to show you, looking at 2025 results, right? This is all the gas units, 20 of them. You look at them, the minimum is 95% EAF, except for the one, our failure, Unkeluk GT12. In March 2023, we had a major generator failure, right? And we've been working really hard to get that unit back. And you can see we have to procure a new generator. The lead times are very long. But I'm happy to say that new generator is on site at the moment, and we're going to commission this in September this year. And that red is going to be a blue, right up there, above 95%. The next is the pump storage units. And you can see majority of the pump storage units, almost all of them, right, except where we had major maintenance. You can see by the green, which is PCLF. The rest of it above 90%. And we've been maintaining that performance all through maybe the last 20 years or so, right? The next point I want to discuss is the OCGT generation load factor. And this has been in the media a lot. And if you look at 2017 onwards, there's been, and we can see, a drastic increase where it peaks in 2024 at 45%. Last financial year, we managed to bring that down to about 26% usage. And this year, we're going to bring that down even further due to the excellent performance in the coal stations in terms of implementing our recovery plan. Another point I wanted to go through on this graph is if you'll notice that the light blue is Khorikwa. Khorikwa has got 5 units, but its load factor is almost twice that of Unkeluk with 9 units. And that's purely because we have a direct pipeline to Petro SA in Mossel Bay. So fuel is not being an issue there. However, at Unkeluk, we have to truck in fuel using tankers, right? And I'll go through some of the logistics there that we have to manage. Right, so we have a good idea, and I'm going to go through it again. The peaking power stations, we know the functions, and we know the performance, right? Now, peaking is not immune to operational challenges. We have a lot of challenges, right? And I just want to go through the pump storage, first of all, right? Now, if we look at the pump storage unit, we operate in 4 modes. We can operate at standstill, where we're not moving or doing anything. We can go into pump direction, and we can go into generating direction, where we have to come back to standstill, change direction, and go into pump, into gen. And then, as I mentioned, synchronous condenser operation, where we put air into the turbine, and then we run as reactive power. That's the next mode, 4 modes. Now, when these plants were designed, they were designed for an average of between 9 and 12 mode changes a day. But over the last 10 years, due to load shedding and supporting the grid and the system operator having the pump storages to come in when it needs to go out when it needs to, we were looking more often than not units running at between 25 to 30 mode changes a day. And what we were picking up was high failure rates on moving parts, right? Things like breakers, switches, bearings, braking system, and the guide vanes that actually regulate the water. We were seeing unusual failures that were coming. We had to adjust how we do maintenance. We had to adjust how we do fault finding. We had to replace equipment. And if you look at mechanical equipment, they are nowadays designed for purpose and not for longevity like how it was. So we have to reevaluate what we put, how we put it in. And that has been a major challenge for us. Right? The next challenge, okay, I just want to jump to the OCGTs. If we look at the maintenance of the OCGTs, right, and we have this equation, EOH, equivalent operating hours. When we reach a certain level, then we have to do a certain maintenance. But if you look at what it's based on, is based on the number of starts, fast loading, fast temperature changes, fuel factor, number of hours running in base load, number of running hours in peak load. But once again, the way our OCGT units have been operated and run in this country, not around the world, it's only in this country that we've been operating it in this way, where we stop, we start. It's an insurance, obviously, right? We don't want to have load shedding. So they run for an hour, they will come down. 3 hours later, they'll run again. So the limiting factor for us is the number of starts that we have. When we reach 250 starts, we do a minor inspection, where we inspect the parts that we can without dismantling. It takes about a week. Costed us a lot of money initially when the OEM did it, but our engineers learned how to do it, and now we don't pay for that inspection, right? We do it in-house. But the other challenge now is you reach 1,500 starts, and you cannot operate the unit until you do a major geo, right? And this is where we are at the moment. So if we look at one of the challenges is, during the load shedding, you could say we had a merit order, we will control how we run the units, but when we needed them, all of them run. So what happens is that all of them start to reach a level where we have to take them out, and we try to manage that. So at the moment, about 2 days ago, Korikwa 21 just went into a major geo, so we're busy with that, right? And and a major geo can take up to 2 months, and the cost of around maybe 100 million a unit. So it is costly, but we have to do it, right? In terms of the stop-start, we see things like, obviously, once again, the moving parts like the coax solenoid valve, which actually regulates the fuel flow. We have to replace them much sooner than needed. It's very expensive. We've been seeing issues with burner performance, right? The burners were actually clogging. We contacted the OEM, didn't get very much results in terms of how we can resolve that, except for replacing the burners. And then we looked at innovative ways of how we can do that. And we're looking at an opening of 0.7 millimeters where the fuel sprays out. And then, amazingly enough, a dental drill can actually be used to open up that area. And we've been trying to maintain that until our next major outage. So things like that we have to do so that we can keep our units running. Okay, now we get to our major our major problem that we're having at the moment, right? And I'm sure everybody in this room is having that problem, which is skills shortage. We've actually lost quite a few experienced personnel over the last 5 years or so, hundreds of years of experience. We've lost to competitors. So I must say, Amazon in the Western Cape has actually wiped out our CNI department, our experienced CNI people, and we are rebuilding that at the moment, right? We have to. With the Eskom cutting costs, we have to do more with less, right? And sometimes, or most times, most of our systems, we have one engineer looking at 36 units across all the power stations. And we have to find ways of how we can do that. When we go out in recruitment, we notice there's a diminishing experience in terms of maintenance and engineering personnel. They just don't have the skills that we need, and we have to look at how we're going to do that in-house. It's a major challenge. And we all know that training of skills takes time. And so that's what we're working with at the moment, high priority. And so we're trying to push that. So that is some of the operational challenges that we have. There's much more. But I want to go through a concept that we use called resilience engineering. Resilience is defined as a system's ability to withstand and minimize the impact of disruptions caused by an external event, as well as the ability of the system to maintain its performance after disruption. If we look at this curve that we have, this trend, right? On the vertical axis is the capability of any system or equipment, and on the horizontal is over time. We can have an event, an external event that comes in. It can be anything in terms of a mechanical fault, a cyber intrusion, extreme weather, which we've had, and it results in a sudden drop in performance, right? Sharp drop. Now, the degree to which a system can absorb that impact depends on its design, level of redundancy, and the condition of your equipment. And we call that the ability to absorb. And what we find is that addressing single points of vulnerabilities is key. And to give you some examples of these, this can be done with a simple redesign or using technological advances. When we found glitches in our temperature probes that was causing our units to trip, and these glitches were a few milliseconds, and we had a unit trip. So what we investigated, and we found, no, we can put a 1-second time delay and alarm the rate of change. So what we do is, every time we have such an incident, it doesn't affect the process, but we know through the alarming that there is something's going wrong with this probe, and we go and we replace it without affecting our operations. In the past, we used to measure flow using flow switches, where it's just on and off, right? And they used to fail, so it caused trips. And we said, no, let's use new technology. So we put analog measurements. We can see the full range of the flow. We can put alarms at different areas. We can actually monitor the performance. And we build our resilience in terms of that. Right? But I also want to say that it also depends, resilience also depends on the competence of the people operating and maintaining the plant. When we find we have an incident, we go in and we say, we don't want to have this incident again. We analyze it, we find a way in which our operators can operate in such a way that we put temporary operating instructions so that when they see we're moving towards this incident, they can immediately intervene and bring the unit down when we want to, and not when it actually trips or actually get out when we least expect it. So that we've been trying to put in place. The other major aspect in terms of improving resilience is that we try to do our maintenance in-house as much as possible. So we control the quality and repeatability, right? And that's has been playing a major role. So now in terms of the recovery phase, the recovery phase that follows is where the full value we see the full value of resilience. Whether the system takes the quickest recovery path, the normal path, or more gradual, it depends not only on technology or spares, but crucially on the skills of the workforce. Skilled technicians and engineers can diagnose faults faster, implement workarounds, and safely restore our operations with minimal risk. The importance of having critical spares and the right skills makes all the difference. Another key factor is quick decision making when we have incidents. We convene our experts, all of us, 2 o'clock in the morning, anytime we convene, we discuss, we make sure that we make a decision to hand that unit back, even with emergency modifications. And to mitigate our restrictive processes like our procurement process, we set up overarching contracts for support and spares so that when we need them, we're able to actually tap into that as soon as we can. And finally, I just want to say in terms of resilience, you will see that on the far right of the diagram, the recovery may not always be 100%. Sometimes we stabilize at a slightly reduced capability, a new normal. But the goal is clear: limit the damage, bounce back fast, and maintain critical operations. We then go back as soon as we can and return to full capacity. Right? That's our culture. So I'm going to run through a few of our distinct advantages that we have, and then we'll go into conclusion. I'm almost there, right? One of the major distinct advantages of peaking is that we always had the culture of doing things in-house. Since the early 2000s, right up to now, we've been doing control system upgrades on our hydro units internally. That was the full design, installation, and the commissioning. We used the OEM to get the equipment and to do final reviews for us. In that way, we built our skills internally. This was also true for maintenance, where we had maintenance teams at each of the power stations. And when we had major geos at one station, we moved all of them there so that they learned the different power stations. And we built our skills internally. Another key aspect is clear roles and accountability. It is very important that people know what to do, how to do it, and when to do it. The one other thing that helps us to be agile, as I've mentioned, is quick technical decision making. And we make sure that we have our own subject matter experts who know our technology like no other person in this country. And whenever we need them, they're there, and we respond and we make decisions. Due to having limited resources, as I've mentioned, we're looking at using the plant data more effectively so that we identify high-risk areas and we deploy our limited resources there so that they can be used effectively. So due to the design or agile nature of our units, we're very quick to go up, but we're also quick to come down, right? We use this opportunity. Whenever we find a problem, right, we bring our units down, we make use of opportunity maintenance. We go in, we repair things as soon as they happen. We do not leave it until they build up to a state where the impact is so much, right? So we go in and we make sure when it happens, we resolve it. Right? That's another culture that we have. Then in terms of decentralized processes, peaking always tries to take the lead, and we try to make processes more efficient. We, for example, looking at the engineering change process where we do the modifications, we own the whole process. We run the whole process within peaking. We look for ways of how to improve things to make it much more quicker, more efficiently, but still working within the governance. And that has been really helpful for us in terms of how we implement modifications on our plant. I want to quickly go through another concept, very simple concept, right? People, plant, and processes. And what we realize, and especially when we do root cause analysis, right, we always find that the root cause comes from either one of these areas. And the one thing is that all three areas must be operating in balance to get optimal performance. When we notice that the people aspect is falling, what we do, we create more procedures. We put more stringent requirements. And what we notice is, more often than not, soon, we will definitely have another failure because we've skewed the balance. We've put energy in the wrong place. If there's an issue on the plant, we must sort the plant issue out. If there's people issues, if there's discipline, if there's shortage of resources, we need to sort that out. We don't overcompensate using other processes. And if we do this proactively, we find we can see these things sliding and we pull back, right, early enough so that it does not become a problem that we can't solve. Last but not least is the culture of excellence, nothing less. We carry a deep sense of responsibility, always seeing ourselves as the last defense, the final Eskom guardians. If we fail, generation fails, Eskom fails, the country feels it. We keep going until the problem is sorted out. That's our culture. In conclusion, I have to say, I honestly wish I was a young engineer in South Africa today. Yes, we are facing some tough challenges, but the opportunities are even bigger. The power sector is changing fast. New technologies are coming in. We're seeing creative, unconventional grid solutions. And there's a real need for fresh research and ideas from our universities. The power utility sector is generating more than just power. It's generating possibilities, and it's moving quickly. But here's the thing. Performance excellence isn't out of reach. It becomes possible when we return to and strengthen the fundamentals. Solid engineering, critical thinking, and teamwork. That's how we build something lasting. For any young engineers out there or people stepping into this field, the potential to learn, to grow, and to make a real difference is enormous. It is an exciting time to be an engineer. Don't miss the moment. Thank you.
Thank you. Good evening, everyone. I'm sure you are excited about questions. And it's not a mistake that I stood up. So, good evening, and to the President of the SAIEE, our past presidents that are in the room, and to our host, the Executive Dean, Professor Mashau, thank you for hosting us today. To our fellow members of the SAIEE in different capacities, and a special greetings to our young ones that are the most and the majority ones and the lucky ones to be doing engineering in these times. I will be facilitating, before I do my vote of thanks, the questions and answers, which you are all excited about. So I'm hoping to see hundreds of hands. And let me not also, in my greetings, forget not to greet my fellow Eskomite and a colleague of mine. It's a different and refreshing perspective, Dr. Ned, to see you from a different angle today, but also as a proud Eskomite for what you have just delivered. I will start now with opening the floor for the questions and answers. Questions, Dr. Nat, if you can just join maybe in the center here, if someone can help me with the mics.
Thanks for the presentation. It was really great.
I wish I had more students coming here to hear about it. Yeah, the 1,000 megawatts. How long can they run producing that? I just got interested to see, yeah, how long can they run? Thank you.
Okay.
Okay.
Let's maybe take 3 questions and then we'll give.
Okay, no thanks. My name is Sello Mullo, and Dr. Ned, for me it's a nostalgic moment when you submitted this. But rightfully so, I think I've got just 2 questions. I had interest in your PCLF, especially if I look at how you're pushing. I look at Drakensberg. I think the last one was the one that you showed us, that it was in Unit 4, where you last took it out for a major outage. How is that? And you've also then indicated to us that you're seeing a lot of failures given the number of changes that you're making in between the different sequences. How is that? Are we not pushing the PCLF too hard, or in terms of delaying the shutdowns that you must take? And also, in line with that, I mean, if I look at how now you're operating, the units are mostly, some of them are almost base load or extended operational time. How is that affecting your opportunity maintenance that you spoke of in the last part? And then the last question then would be on resilient engineering. The fact that you're losing a lot of skills, and if I look at it, really it hangs on having the right people with the right expertise. You did not maybe indicate to us how you're leveraging on digitalization. You mentioned that you do use it, but I did not get the actual digitalization that you are implementing. And I think for me, the single point of vulnerability is an interesting concept that we are also speaking of single point of failure. I think it's the same concept, and it's interesting to see how you approach it. Thanks.
Thank you. Given the number of questions, let's pause.
Okay, right. So the first question in terms of how many hours we can run in Gen. So we got 4 units, right? And so what we do is we got a cycle in terms of generating. So we can generate for at least between 6 to 8 hours continuously, right? So it's long. And so what we do is during the week when we generate, we use up, but we also pump at night. So we make sure that it's always replenished. When we have strain and we have to produce for a long time, that's why we run the OCGTs. It's amazing. It's so expensive, and we pump with that. It's actually painful, right? But it hasn't been very often that way. But when it is real emergencies, then we have to replenish, right? And obviously, Drakensberg being a black start, there's a limit where we can go, so we don't eat into the black start if we need to. So we maintain that also, right? Mm-hmm. Okay, and then in terms of Unit 4 and the maintenance that we've had, there's been some major upgrades, right? But in terms of the factor that you mentioned, we have different maintenance routines, right? So we have the brush gears where we things that really move. Then we do that every 3 months, right? And then on an 18 monthly basis, then we have like a mini geo where we inspect and we make sure we try to resolve some of it, and then the 36 monthly, right, which is every 3 years or so, we do the major ones, right? And this is what I've shown you now, where we caught the major. But what you're saying is correct, because when we're in the heart of load shedding and we have to gen and we have to always gen, we look at our maintenance, what needs to be done, and we do risk assessments, right? Each of the engineers will look at and say, can we miss this opportunity? But we always make sure the next round it's done. Otherwise, it does catch up. And that's how we manage that. In terms of the resilience, yeah, so as I said, it's one of the biggest risks in terms of people. In terms of using technology, right? So simple thing like GPSS data. Okay, we call it GPSS, where we record all the data in the power stations, every incident, every run-up. So what we've done is we've looked at all the trips that we've had, right? And we use Power BI. I can actually demonstrate that if you want, right? But so looking at from 2009, the information right up to now, I can tell which systems have been affected the most in the current year, what is giving us problems. And then we use that to direct our engineers to there, right? Where sometimes we don't have engineers, but we have to bring from a different system to actually help us to get that. But information is very important. Yeah, I think I've answered.
Can I abuse my ESCOMite role to support you, Prof? Then, in terms of using peaking also as a long duration type of energy storage, we are also in the past year have been looking into alternative types of long duration energy storage that we'll be piloting in the next year. So we have about 5 options that will be on top of having the hydro, and that includes, for example, one of the options will be what is being implemented in China. When you look at they've got about a 300 megawatt plant of a compressed air solution that uses, I think it's more on under a Minecraft type, which looks like more hydro, but under, and also on one, I think it was an energy vault solution that also uses ash brick stones for pumping up the energy. So we've got about 6 types that we'll be implementing in the next few years, and that would then be bringing the issue that we're looking at into how are we running the base loads using peaking station, but also reducing the issue of costs. So in the next few years, 3 years or so, you'll be seeing a number of alternatives to support the base load technologies. Thank you. Let's go this way.
So you mentioned that without peaking, the energy utility sector would be under severe constraint. I'm not sure if you are aware of the new innovation that has been brought by the eThekwini municipality, whereby there's a new electricity generation capacity, which has been approved by the Minister of Electricity, Dr. Hosienzi Ramakgopa. So according to that program, it said that it's going to procure 400 megawatts of energy, of which 100 is solar PV and the 300 is gas to power. So that is, I'm sure that's a very, very financial and also mechanical sound initiative. But now, according to the infrastructure that is severely dilapidating in South Africa and failing, do you think such initiatives can be implemented? And do you think more risk assessment needs to be done before such initiatives can be implemented? Because there are many innovations that have been put up front and they were sounding promising, but they haven't been implemented. And some of them have been quoted as like, no, they are going to have a significant impact in the IDP, Integrated Development Plan, and the National Development Plan, even SDG. So do you think such initiatives can be implemented? And if eThekwini municipalities as a metro implemented, can City of Joburg and local municipalities implement it? Because its focus is on low carbon energy technologies. So would it be, like according to you as SAIEE, South African Institute of Electrical Engineers, do you think such initiative can be implemented or would have a long-term effect in eliminating the constraint in the utility sector of South Africa?
Okay. Good evening, colleagues. I'm Nkosinathi Matushele. I'm a staff member and my boss is right in front of me there, Prof. Mashao. Thank you for the presentation. It was very interesting. You did mention that you have a lot of historic data, but you also talked about the lack of skills. I'd like to know, how are you using that historic data with the advent of machine learning and all of those things to train models with that historic data to better inform your decisions moving forward? Do you have those skills in-house? Are you building them, or are you collaborating with others in utilizing that information for these AI technologies? Thank you.
Thank you very much. My name is Teboho Machabe. Firstly, I wanted to ask you about the cost of running these OCGTs on the network. But you mentioned that it pains you, so I don't want to add to your pain. I'm sure it's quite expensive. My question is on the two peaks that we have, right? With the advent of possibly a high volume of EVs on the network and climate change and also household opting for battery backup solutions, are we seeing or anticipating a third possible peak on the network? And how is your peaking station going to handle such peaks, maybe 3 or 4 more peaks on the network? That's the first question. And the second question is, why is BESS not part of your portfolio?
The first question, right? Okay, so it's out of the scope, but I'll answer it. I'll try to answer, right? So the thing is, as a country, we have to do things. We have to look at how we're going to bring new energy into the country, right? And I must say, you know, our network is a challenge, the transmission network, and we are aware of it. So there are plans in place to roll out. In fact, I think it's like 14,000 kilometers of network, but we need to move with speed on that one, because as I've mentioned, new technologies are coming in very quickly, and we can't hold back on that waiting for something else to happen, right? So we need to build and drive and put the pressure in those areas so that we can align eventually. But so I'm all for that, you know, if we can bring new energy sources, new ways of doing things in areas that need the energy and does not have that. And the main thing is, you know, we're saying we got extra power, but there's so many people in this country don't have power. We need to be rerouting it to them, to everyone, and the opportunity is there. You know, if the people who can afford it using PV, then they must do it. But we must use our rest of the energy for people to energize the rest of our population. So yeah, so I hope that answers a bit in terms of it. We should have it, and it's good that we have these initiatives, right? Okay. Yeah, so in terms of the data that's there, I think the main thing is to like demonstrate, and I can demonstrate that for you, right? But the thing is, in terms of power transformers, I'm absolutely passionate about power transformers. I didn't let it go, even though I'm in management. I pride in being a specialist in power transformers, and I've created models in terms of looking at how a power transformer is performing, how it's going to last, when is the fault going to happen. We part of CGRAY, so we bring that information in. I've used so you can automate all the different methodologies of identifying a fault, looking at insulation breakdown. So that I've done, and we've been using it in peaking at the moment. Yeah, so things like that, and in terms of, as I mentioned, AI is something that I'm really looking forward to the universities to help us with, right? It's an area where I'm also interested in, and we need to look at how we can predict things happening, right? The information is there, but we just need people and resources to do that. Our existing people are looking at the plant. They really want to, but they don't have the time to go to the next level, right? So we need to have collaborations, having a look at that data. It's available, and we need to work with that, right? Okay. And then in terms of the cost, yeah, you know, okay, I don't want to say cost because it changes all the time, but it can go into a few thousand per kilowatt, you know, in terms of OCGTs. But the thing is, the new technologies that's coming in. Okay, so the one thing you asked me in terms of the cost, I just want to make sure that if it's so much. Okay, I'll answer the one about the BESS, but I just wanted to understand the one question you asked about the OCGTs.
About the OCGTs?
Yeah.
Like the cost of running an OCGT
yeah.
in an hour, for example.
Yeah, no, it's a. Yeah, so the other thing that we can burn a tanker in like, if we're running all units at Ankerlijk in like a few minutes. So if you look at our cost last year was like 20 billion or so. It's a lot of money. So we, so in terms of the amount actually changes a lot. But all I can say is that when we run over a weekend, it can be a few billion. It's a lot. I looked at a model that was showing solar and wind. There's no peaks anymore. There's new peaks. So the peaks, so what's happening is between maybe 10 o'clock during the day to 4 o'clock right? Because of all the solar we got in the country, there's an excess supply during the day, right? So what you're seeing is an excess supply during the day, right? And so what do you do with that energy, right? So that's the thing that is looking. So then we have to, so we use BESS. Maybe BESS is the way, right? We can store that energy for the evenings. And so the profile as we go into the future is going to be totally different. It's going to be, but we need to have research on that. We don't know that as yet. As you mentioned, we're just putting things, a plant here, putting a plant there. The network is under strain. You know, we're seeing megawatt, our power stations just swinging in terms of the megawatt, because if you got a solar farm and a big cloud comes through, it's gone down, you know. But so the one thing we need to be aware of is that we need a base load, right? We need a base load. And then we can use all these other energies. But the base in the future, right, it's not going to be coal, right? So we need to find that other base. So they're using gas, right? Maybe, so we're looking at converting our open cycle into combined cycle, right? But obviously you have to get the fuel and the cost, but that's what we're looking at, and that can run continuously. That can be a base load. Yeah, so in terms of BESS, why is BESS not part of peaking? It's because BESS is best being on the actual network all over the place, and it's most suited towards the distribution, right? So that's where it is at the moment. You know, you can't, the peaking plant is, we actually manage things that are moving. You know, this thing is there. It's an inverter system, I mean, and a battery system. If it fails, you replace, so it's modular, right? But it needs to be in localized areas all over the country, right? And it wouldn't really fit into the peaking space, but who knows, right? Who knows? Yeah. Okay.
Just to add more onto the BESS one, we are also looking into using BESS versus synchronous condensers on the load as well, looking into grid forming with BESS. So it would not necessarily be in peaking, but looking into the functionality on the transmission and generation as they are as they are unbundling and looking into new services that would come into the package, not necessarily under peaking, but if you look into the whole portfolio of generation, you would find it's in that portfolio as well. And just to add to the question you asked around the edition and what the minister has approved, if you look into the priorities of the ministry, there are 3 key drivers there. One is the energy security, and the 6 million still to be without access of electricity. The second part is looking into, we're no longer talking about just energy, but we're talking about just, affordable, accessible, and inclusive energy. The third priority, we're looking into the interconnectivity with Africa. So if you zoom into what energy security means and how we're making it accessible and what those options then come in to say, is it a good thing to do? What does it mean? But it's about balancing the grid once we've made those options of accessibility to the people, closer to the people, and that's what is trying to close in the energy security gap. So as much as if you look at in isolation, it might or might not make sense, but if you look holistically into what it's trying to address and balancing the priorities the ministry, then you'll understand it holistically. Thank you. I'm abusing my role I'm abusing my role as a facilitator, but as a fellow ESCOMite, I think it's important to bring out some of the aspects that you look at this holistically.
My name is William Stuckey. I've got 3 questions and 2 comments. The first question is, you mentioned that the wind power was part of your portfolio, but you said nothing about them after that. As they're not dispatchable, I wonder how they actually fit in peaking. The second question is you seem to have got a different culture and a different approach in the running your peaking group. As opposed, what do we need to do to get the generation people to learn lessons from you?
Just remind you they're part of.
But I am generally, you can see we are improving, but okay, let me answer as we go along, yeah. And you got one more question.
One more question.
The comment is that BES, or BESS, is a battery energy storage system, and the current sizes, to the best of my knowledge, are around about a couple of 100 megawatts, typically with about 4 hours storage. That's not big enough to make a difference to the grid, but it is big enough. It's energy storage, but it is big enough to be used for ancillary services, frequency stabilization, synchronous capacitance, and so on. And then my last comment, and it's aimed at Dean, there's quite a lot of research that shows that AI makes you stupid.
Okay, so the first one in terms of wind, so I must say, SAIEE wind farm, as I mentioned, is the only one at the moment, right? But it's been, the last 3 years, been performing really well, 95%, how would you put it, availability, 20% load factor that it's been producing, right? So it's been really contributing, and the wind has been blowing up in Vredendal. So it's been really good. I didn't say much about it because I was talking about our 36 units in terms of hydro and the rest of the gas. But there's a lot of new builds coming. There's a lot of wind that's also coming through, and I'm not sure where it's going to reside, but yeah. So in terms of that.
Why is it peaking, not generation?
Why is it peaking, not generation? Oh, I see that. Okay. So we were also looked at as being part of renewables, right? So initially, the peaking portfolio a couple of years ago was renewables also, right? But you can see with the explosion of renewables coming into our country, it's another operating unit on its own, right? So the company has now looked at that, and there has been some changes and movement towards that. So renewable has its own operating unit that we'll see more of as we go along, right? And then yeah. The culture part, okay. The culture part, the Eskom generation culture is really improving, and we're all working together, and peaking is involved in all forums in terms of how we do things, and I must say it is improving. The only thing is, the nature of the coal stations and where they were. It was a very difficult situation because we let something build to a state where it could not be solved very quickly, and the people and the engineers, they actually took a rough rap on that, because if you look at the technology that we have, if you're going to make a change on the system there, it takes a while, and so in terms of the culture, I think within our generation at the moment, the culture is excellent. We're all aligned. We all know what to do in terms of recovery, and yeah. So I can't say anything bad about that, right? So we're all improving. And then there was one more that you asked me.
I forgot my second question.
But I had a good answer for that one.
over dinner. We'll answer that
dinner.
over dinner.
Right.
So, William, just to emphasize the point, peaking is part of generation.
Yeah.
So the culture is generation. Yes, Mike.
Prudence. So I'm going to share some history with you guys.
I am me.
Mark Barker, heavy current engineer. Not unlike my colleague there who's a bit light current. Okay, so back when I was a final year student, we drove up to Drakensberg when they were still building it. Okay, the civil engineers were there. They made us drink a lot of beer that night, and some of us fell over. Okay, so it was dangerous times. I'd like to thank you for your presentation. In the last 40 so many years, this is the best presentation I've heard on this subject. And I think you're all very lucky here tonight to take part in this. Thank you very much. My question... Okay, so my question is coming at it from a different angle. The peak doesn't have to be there if we can control the peak. What about demand response? What about energy flexibility? In the UK, Europe, elsewhere, even China, they're looking at controlling that peak. If we didn't have the peak, you guys wouldn't have to do what you do. Yeah. So there's an animal called a grid interactive efficient building. And a lot of us over at the IEEE and elsewhere are pushing the idea of buildings playing a part as being good grid citizens. When there is a peak, the message gets out and they turn down. They don't have to consume that much energy. A lot of buildings these days have battery. So we believe these good grid citizens can contribute by seeking beneficial coexistence with the grid. I really think we've got to get South Africa thinking, and all of us thinking, we've got to help Eskom, right? There's only one grid in this country. It's our grid. We've got to look after it. How can we help the grid? In the good old days on TV, they said switch off the energy. So I'd like your opinion on the grid flexibility. How do we flex our load to help you guys? Thank you.
No, absolutely. And I remembered what you asked me. So it was on the BESS being 4 hours, right? If we got BESS for 4 hours straight after solar, we can use the BESS and save the pump storage for a little bit later. So in terms of managing that also, you know, we can see what energy we need to use now, right? And there's also CSPs also, you know, so that can drag out a bit. And absolutely, I agree with what you're saying. You know, it's a culture we need to build in the country, where in the past we had energy excess, let's put it that way, right? And we didn't think about it. But now each of us need to see how we use that energy, how we bring it in, and change maybe our lifestyle or whatever it is, right? But the thing is, we still got a long way to go, because we need to electrify so much more people, right? That's the core for us at the moment. You know, we need to bring more people in the party, right, in the group, so that we can all contribute. And when we do things, we need to think energy efficiency first, you know, and going. But those new technologies, I think around the world, they're more mature, but we need to be aware of it, and we need to integrate it now in terms of our designs, how we design a new plant, how we design BESS. Maybe we can already put that in there, so that in the next 5 years, 10 years, it's a no-brainer, it's there, right? But that thinking is very important to bring in. Thanks.
Thank you. I'll have to cut the question here, and we'll take them with during the last. And yeah, because Gerda is giving me, that's why I can't, I'm like even afraid to look. She's like, I told you, 30 minutes is gone. Okay, let me take the last question.
At present, Eskom seems to have, according to the media at least, quite an adversarial relationship with small-scale embedded generations, particularly solar. Whereas in many countries or states, the situation is completely different. There are people operating as a virtual power plant where they're aggregating the capacity of small-scale generators, as we call them, people's batteries and inverters in their homes, and are supplying power to the grid when it's needed, and abstracting it or returning it when it's not needed, or simply supplying it to the grid when needed. What are your comments about that as a peaking approach?
Yeah, okay. It's not a peaking approach, but I'll answer because so the thing is, at the moment, the solar being installed in terms of individuals and businesses is all over the place, right? Now it introduces a risk in terms of our network and how we manage it. So we need to be careful of that, because in certain areas there might be excess that we may not be able to either import into our grid, or to actually manage that. So what we're looking at the moment is actually protecting what we have, right? In terms of what you're saying, that is the future. We need, in terms of solar energy, it's free, it's coming down, everyone wants to use that, right? But the thing is that we need to see how we integrate it into our system. At the moment, there's a lot of rules that we're putting, but it's more to actually protect us or the grid, because we might not, if we have to open it up and say everybody can supply, we might not be able to handle it in different areas, different regions, and we need to see how we do that in a proper way.
The concept of a virtual power plant is really up and running in Western Australia, for example.
Yep.
Okay, it's already done.
Yep. No, I understand that. So,
Just in on the work that we are doing. So we have been doing studies on that and also modeling the network and the impact on the network. But in parallel to that, which we will launch in the next year, we are reviewing the costing model that comes with that and the NERSA regulations and tariffs that are being reviewed. The targeted date, which I'm not sure it would be done in terms of what distribution is targeting, is and by the 1st of April next year, that we will have defined the financial model and how we then, from a customer perspective, from the ESCOM side, we do that costing model. The target is sometime next year, but I'm not 100% sure in terms of the status of readiness from the NERSA perspective. But the modeling and the analysis of that work, it is currently being looked at from a distribution perspective. We are also in parallel from distribution, having a project in terms of just answering in terms of smart customers modeling and how that will work. There's a project from the distribution side of rolling out smart meters and how we'll then control and function those. It's currently one of the flagship projects within the distribution side, and that supports this GSM question that you asked and how we'll bring. But also, it's not only from the ESCOM side. When we change in that, we change the regulation in terms of how we're managed. We'll also change our costing structures, because you cannot just put out a model without knowing how you will then do the costing from both sides and how the impact of the network and will regulate this. And that's where the issues around grid stability then comes in and modeling of that so that we're prepared for that system. It is not new. It's about contextualizing it into the South African part. But remember, in doing that in the past 3 years, and we're now busy unbundling the distribution side. So it comes with a mixture and setting up those. So it's not that it's not looked into. But within the research space, we're doing the studies. I'm abusing my platform for the last time. Mm-hmm. Yes. Okay. Gerda is not going to be happy with me. The gentleman at the back has been insisting, then we cut from the one sitting next to Tebogo. Then I'm going to close off. After this, I'm sure Dr. Ned will sit here for a few questions that you can. I didn't know ESCOM was this interesting. Hey, now I know. Now I know.
Hi, evening everyone. My name is Vus Chabalala. I think I just have an interest in just understanding why is the tip of a needle or the absence of a discussion on nuclear energy for the country. I just want to know who is pressing the brakes and what exactly is keeping us away from an open forum discussion around this particular subject. And then the last one is, No, it's just we know we've been losing skills to competitors and everyone. Do we have a plan in place to reconfigure ourselves to develop the skills that we have?
Dr.
You're gonna-
Nant,
you're
do you
gonna
want
take
to
the
take
first one?
those one? Yeah, let me take that first one.
Yeah.
So, so if you look into, and I'll take it from an ESCOM side, we are waiting for the determination on the IRP, which will come soon. So you'll see our placement in terms of the nuclear program and the new build that have been allocated for ESCOM. We have and again, if you look into the work that's been done for our ministry, we are positioning NEXA as well in terms of revitalizing the skills around that, and the PBMR is also going to be revitalized through NEXA. So there's a lot of investment in terms of nuclear, and you look when you see the revised IRP in terms of I won't mention the numbers, but it's a huge chunk of that is going to go into the nuclear. We've been having the conversations around nuclear and the emphasis, and I will go again, if you look into the President of South Africa on the G20, and the emphasis on nuclear as an alternative energy has been on the key front of what we're talking about. So it is in the discussion. There are challenges around the positioning of nuclear, and I remember when we had the first energy transition work group and the second one in April in Cape Town, and we had a visit to Gubech. When the power station manager stood up, Velapi, asked the question to say, who in the room advocates for renewables? Okay? There were lots of hands that were raised. Then he said, wow, clap hands for yourself because you're doing a damn good job. And where was that coming from? He says, if you look into the history of Gubech, we have now been extended Gubech. No one makes noise about that. It is silent. If you look into the experience of South Africa and the positioning of Africa, although now Egypt will be overtaking us when they commission their units, the knowledge and the capability that we have within ESCOM on the nuclear in the continent, we were the first. We still are. And even if they overtake us, we'll still remain in the first. And come the next IRP, and what we'll do, it will reinforce our position in the African continent. So the discussion around nuclear, it is. Maybe it's the advocacy around nuclear that we're not positioning it well. Talking about skills, if you look into and yesterday we are again launching the program for leadership development, relaunched within ESCOM, and the emphasis around the skills and build up, starting and emphasizing that on the leadership side, and the commitment still continues. And it's a pity that, and I looked at Dr. Moodley's slides, and I'm like, we talk about skills and skill shortages, but if you look at the capacity of what we have, and he's one of examples of those, then sometimes I wonder if you're positioning the topic in the right way. It's another discussion. Thank you. Let's close the questions here. Thank you.
Okay,
Let me take this opportunity and thank you to our president for choosing you today. I did not know that you were at university together. At least now I know something about the two of you that I did not know when I came to this meeting. But you also gave just a re-emphasis on the importance of understanding the challenges that we have in our country. As we're moving into creating a transitioning path that is just accessible, affordable, and inclusive. The role of peaking stations, the role of renewable energy, the role of alternative energies that are cleaner on our grid can never be overemphasized. And the slide that you brought in terms of what are the options and functions of just the peaking and other sites that people might not be aware of as we look at these units as just generating electricity. If you remember the Spain incident, the Portugal and Spain incident, and the effort that we're putting into stabilizing our grid, you'll appreciate the role that our peaking stations are playing, and you really put that into a simple language to emphasize it today. So I'd like to really appreciate it on behalf of all our fellow engineers that are in the room, whether electrical or not, that are in this room, you have simplified that role for us. And for me personally, I think re-emphasizing the importance of the role that we're playing in stabilizing our grid can never be overemphasized. And you have done a great job in simplifying what is a complex engineering problem that we are trying to solve. And on behalf of the institution, I'd like to give you a small token of appreciation from the SAIEE. Thank you.
Colleagues, we've come to the end of the program for today, but before I draw the evening session to a close, I need to actually provide a response to the question that was asked here about the 400 megawatts, because I am employed at the eThekwini municipality. I'm part of the executive that's running the high voltage operations, but I also need to be guarded in my response to all the Escomites. I also owe 14 years of my career to Eskom, having worked in distribution, transmission, and Drakensberg, by the way. So let me give a mature response to it. When it comes to the 400 megawatts in terms of the Section 34 ministerial determination that was issued last week Friday in eThekwini, this is a journey that we have been on for more than 3 years now. And we actually were quite elated last week Friday when the minister was with us announcing the go-ahead for the 400 megawatts. And it all stems from what our customers have been asking us. Our customers have been asking us for three things in eThekwini, and I suppose they're asking the same for all other municipalities and metros. They're asking for energy security or reliability of supply, in other words. They're asking for price predictability or price certainty. And thirdly, they're asking for green electrons. So we had to go down this journey of trying to see where can we give them these three things. Give them security of supply, give them price certainty, and give them the green electrons. And hence we had to go down this IPP path for 400 megawatts. Now 400 megawatts is substantial. At our peak a few years ago, eThekwini electricity was taking from Eskom 1,950 megawatts, which is substantial. It's quite huge. But because we could not give our customers these three things that they were demanding from us, they decided to go on their own and start generating their own rooftop solar power. And based on that, our demand currently is 1,650. In terms of our network development plan, 10 years ago, we should now be at 2,300 megawatts. We went the opposite direction. So we have to curb this loss in sales by giving up to our customers what they have been asking us. And hence we are glad when the minister made this. Your second comment is in terms of the infrastructure and how are we going to absorb the 400 megawatts. I agree with you, it is substantial. And we are looking at taking it into our major substations. So one of our 4 intake stations from Eskom. So either Ottawa, Durban South, Cloudwater, or Lotus Park. So it will be at a transmission level that we will be absorbing the 400 megawatts. So I hope I've answered your question, but we can discuss it over dinner as well. Colleagues, we've now come to the end of the program, but I need to acknowledge the presence of a few individuals that are part of the session today. Very importantly, I want to thank every one of the council members that are here today. I certainly appreciate your presence and your attendance today. I made the appeal to you a few weeks ago and said reserve this day, and I can see you are here, and I certainly appreciate it. Very importantly, let me acknowledge the presence of immediate past President Pascal Motswasele, seated on my left-hand side. Certainly Deputy President Prudence Madiba, thank you. Junior Vice President James Motladile, that's with us. And I hope I haven't missed out any of the office bearers. I think these are the office bearers that are with us. Okay. So, yeah, thank you to all. And then lastly, let me also give you whet your appetite for the BP lecture, Bernard Price Memorial Lecture. That may answer the question that came from the end in terms of the nuclear generation. The speaker for the Bernard Price Memorial Lecture will also be a former student colleague of ours, Timbani Bakula, who's with the regulator, so he has accepted my invite as well to present the BP lecture. So it'll be nice to have the regulator be present, and he can answer those questions for you. Okay, so I think he's cast to prepare for that. Colleagues, with that said, I want to draw the session to a close. I want to also thank the Dean for making the venue available, and I would like you to join me for dinner after this. Thank you, everyone.